So here is our next example. Find Ix by using the source transformation theorem. So since we are doing the source transformation theorem, don't mess with that 100 volt source, since we need to find the current in that 100 volt source. Okay. So if you look at here, we can combine or we can transfer this 8 ampere source and 50 ohms into a voltage source in series with resistor. So I have 8 ampere in parallel with 50 ohms. I can transfer this into a 400 volts and 50 ohms, A and B. Same thing, another end I have 30 ohms in parallel with 60 volts. So I can transfer that into a current source in parallel with resistor. So I'll end up with 30 ohms here, and this is 2 amperes. Okay, so X and Y. Now I'm going to bring them back, connect them back into the original circuit. So when I connect them back into original circuit, okay, here it is. I have a 400 volts now, 50 ohms, and then I think I have the 30 ohms there. volts Ix, I have 60, 30, 2 ampere. Now we can combine 60 parallel with 30, and you can combine here 50 plus 30, 80 ohms. So after simplifying this, we will end up with a 400 volt, 80 ohms, 100 volt, 20 ohms, 2 ampere. Now if you look at the circuit, it's look like it's easy for us to transfer 20 ohms in parallel with the 2 amperes into a voltage source in series with the resistor. But if you did that, then we will end up with only 2 loops and we cannot proceed any further. Okay. Our goal is we want to make this as a single loop at the end. We want to have this as a one loop. So to make it as a single loop, what I'm going to do, I'm going to transfer that 400 volts in series with 80 ohms into a current source in parallel with that 80 ohms. So 400 divided by 80, that's 5 amperes. 80 ohms. I'm not messing with this 100 volt since I need to find that Ix there. 20 ohms, 2 ampere. Now how many nodes are there in the circuit? How many nodes are there in the circuit? There are 2 nodes, right? So can I shuffle the elements? If I shuffle, still they are existing between the same nodes, so it's not going to make any difference. So what I'm going to do, I'm going to pull all the current source to one side, 5 amperes, 2 ampere, 80 ohms, 20 ohms, sorry, this is the 100 volts, okay. Now you can see that still my goal is finding Ix there. So can I combine those 2 current sources? So if voltage sources are in series, we can add them, okay, based on the either add them or subtract them depending upon how they connected. If they connected in the same direction, add them, opposite direction, subtract them, the voltage sources. Here if current sources are in parallel, then we can add them. Okay. So since those two current sources are in parallel here, we can add them. So what is the total current coming out of these two sources? At the end, I'll end up with 7 amperes. 80 parallel with 20, that's 16 ohms. So I'll end up with 16 ohms there. Okay, 100 volts there, and that's what it is. Still my goal is finding Ix. Okay. Now I can transfer this into a voltage source in series with resistor. What is that voltage source value? Is it 96 volts? Sorry? Oh, 112? Okay. That must be 112 volts. And you have the 100 volts there. So our goal is still finding Ix. So what is Ix? Ix must be 112 minus 100 divided by 16.75 ampere. Positive, right? Should be negative. Why is that? Oh yeah. Yeah, it should be a negative current because the current direction I gave you is wrong. So let me erase this part. So Ix must be, current is flowing from 100 minus 112 divided by 16. So minus 12 divided by 16 minus 0.75 ampere.